This lesson we need to look at covers exponents. This curriculum really crams a lot of information into one lesson of exponents, so we're going to break this up into a couple of different lessons so you won't have any textbook homework for a couple of these lessons. Okay, I want to point out one thing here. You need to pay attention to parentheses when we're dealing with exponents. So if I have 2 squared versus negative 2 squared versus negative parenthesis 2 squared versus negative 2 squared. Let's talk about all of these things. Here's the thing. The exponent only affects what is directly in front of it. So in this case, I'm squaring the 2. 2 times 2 is 4. Now pay attention here, because this exponent is only going to affect what is directly in front of it. This is not directly in front of that exponent. So technically, I am not touching that negative. It is just staying put. And then I'm going to simply square the 2. And actually, this one doesn't even, we don't really need to even look at this one because that's not that confusing. But this one, the exponent will touch and deal with whatever is directly in front of it. But this negative 2 has a set of parentheses around it. Parentheses are kind of like the bread of a peanut butter and jelly sandwich. It pushes what is inside of it together and sort of forces it to be one thing. So while this exponent only affects what's directly in front of it, because of those parentheses holding the negative 2 together, in this case, I am squaring a negative 2. This negative is not being touched. But what I actually am doing here is negative 2 times negative 2, because those parentheses stick it together. So I'm going to keep this negative. Sorry, I'm going to do my answer right up here. This negative is not, oh goodness. This negative is not being touched. It's going to stay right here. Then negative 2 times negative 2 is positive 4. And we'll do another one of those in just a second. So let's look at another one of these. Let's talk about negative 3 squared versus negative 3 squared. Again, the exponent only affects what is directly in front of it. Directly in front of this 2 is simply a 3. This negative is not being touched, which means it's just going to stay put. And then I have 3 times 3, which gives me negative 9. Now the second example here, remember, the exponent deals with what's directly in front of it, but these parentheses stick the negative to the 3. So what this means is negative 3 times negative 3, which in this case is then positive 9. So really watch those parentheses, because whatever is inside of it gets stuck together and I can't pull it apart. It has to stay as one unit. I'm going to put a couple of these here for us to try as just a review. 3 to the 0 power, negative 3 to the first power, 6 squared, negative 6 squared, and then let's do negative 6 squared like this. What I would like for you to do is to work these problems, pause the video, work these problems, and then push play again and see if you have them right. Take a second and work these and then come back and check them. All right, let's talk about these answers. We have 3 to the 0 power. Remember, the rule is anything to the 0 power equals 1. Always and forever, anything to the 0 power equals 1. This 1 is going to affect this, but it is not going to affect this because there is no parenthesis keeping that negative stuck to the 3, so it's kind of like a separate entity. So what we're going to do is we're going to keep the negative, and then 3 to the first power is just 3. 6 squared is 6 times 6, which is 36. Negative 6 squared, this touches what's in front of it. This negative is not being touched, so we're going to just keep that, and then 6 squared is 36. All right, these parentheses, stick this negative 6 together. So what I really have is negative 6, oops, that's not a 6, times negative 6, which equals positive 36. All right, let me put a few problems on here for you guys to try. Let's do 16 to the 3rd power times 16 to the 5th power. Then let's do 7 to the 9th power divided by 7 to the 4th power. That's not going to work. Divided by 7 to the 3rd power, 7 cubed. Okay, remember, if you're multiplying like bases, you add the exponents. If you are dividing, you subtract. Multiply, add, divide, subtract. So try these two problems and then pause it, try the two problems, then press play and check them. So let's talk about this first one. Remember, multiplying means we add exponents. 3 plus 5 is 8. So this is going to be 16 to the 8th power. And again, we're only being told to simplify, so we stop right there. On the second one, if we are dividing, we subtract. 9 minus 3 is 6. And because we're simplifying, we can leave it right there. The next topic in this lesson of exponents in this textbook has problems like this. Now, this is not the last concept in the actual textbook lesson, but it's the last one we're going to look at. And to be honest, I don't really understand why your textbook teaches you this the way that it teaches you to do this. Because when I look at a problem like this, and I know my order of operations, I am supposed to solve inside my parentheses first. So instead of learning another way to do something, I despise that about mathematics. They teach you 15 ways to do something when one works. So instead of learning something else, if you were to look in the textbook, I want you to kind of ignore. They want you to sort of expand this out and then do some more work, and it just is kind of silly. Because order of operations tells us to solve inside the parentheses first. And if we're told to simplify it, we're going to stop right here. If we're told to solve it, we're going to solve it. I will go ahead and just show you right here the way the textbook wants you to do it. It wants you to put this 2 with each thing, 3 squared times 5 squared, which is 15 squared. It's the same thing, okay? So don't do it that way, because that's 2 steps versus just multiplying and being done. Just solve inside your parentheses first. Okay, here are 1, 2, 3, 4, 5 practice problems. I would like for you to work these 5 problems independently, and then we're going to do them on this video. I'm going to work them out on the video and walk you through them. So, you know, if we're having to do this virtually, if we were in class together, I would make you all pull a piece of paper out, make you work these, and then we would check them together. So we're going to pretend that we're in class together. You're going to pull a piece of paper out. You're going to work these 5 problems. Pause the video, then push play, and let's check them. Okay, let's work these problems. But all of you have already done them, so what we're going to do is we're going to be checking them, correct? All right. Anything to the 0 power is always and forever 1. Anything to the 1st power is always and forever itself. All right, remember, if we are multiplying like bases, we add the exponents. So our base stays. 4 plus 3 is, whoops, that's not a 7. 4 plus 3 is 7. If we are dividing, we subtract. Our base stays. We subtract our exponents. 6 minus 4 is 2. And then on the last example, let's ignore the textbook way to do it and do the easier way, which I think is the exact same problem that I already did, but that's okay. 3 times 5 is 15, and we keep our exponent. All right, here are 12 problems for you to try. So you can pause the video here, write these down, and then work them on a piece of notebook paper that you will turn in on our next face-to-face. I would like for you to, for your title, put exponent lesson 1. That's what you need to label this lesson, and then work all 12 of these problems. Bring it with you on on Tuesday, and we will check them and go over the work.